In this lesson, I will explain to you the concept of neural network. What is neural network in artificial intelligence? This is one of the most important topic and I will try my best to make it as easy as possible. So here I have written some information. First I will read it, then I will explain to you with the help of some example. So a neural network is either a system, software or hardware. Means it can be software or hardware that works similar to the tasks performed by neurons of human brain. See, the focus is neurons of human brain. Our brain consists of billion of neurons which are connected to each other, or simply you can say there is a network of neurons and they take information and we receive the output. Here I want to give some very simple example, then you will understand very well. Suppose we have a hot stove and you touch the hot stove. What will happen? Less than second, it will take less than a second, you will remove your hand from the hot stove because the information will go to the neuron, and then with the help of these neurons we will receive the output that the stove is hot. And this is our experience, we learn with the experience. Right after that second time, if the stove will be hot, we will not touch the stove because we have learned through the experience that it will burn our hand. So whatever our brain do, now the same function we want that machine should also perform the same function as our brain does. So that is why it is called ANN, or artificial neural network, because here we are going to train the machine that you have to perform just like the brain. So ANN is the component of artificial intelligence that is meant to simulate the functioning of human brain. Processing units make up ANNs, which in turn consist of inputs and outputs. So what is the meaning of processing here? What is input and output? I will explain to you in this lesson. The inputs are what the ANN learns from to produce the desired input. Means input is, you can say simply, raw data or raw information. Initially we provide to the machine and the parallel processor performs some actions on it and will receive the output. And these are the important points: deep learning and machine learning. Why I have written this with the red ink, it's highlighted because if someone asks you where we use the neural network, then you have to say in deep learning and machine learning. Right, again, if you will read this very slowly, whatever I said, the same thing I have written here, but this is again highlighted. The artificial neural network is designed by programming computers to behave simply like interconnected brain cells. And there are around 1000 billion neurons in the human brain. Now, if someone will ask you, give some practical applications or practical example where we use the neural networks. So Google Translate, Google Assistant, Siri, these are the main application you can say. What is going there? If I say Siri, please set alarm at 4:30 a.m. and within a second she sets an alarm for us. What is going on? What is the story behind it? Neural network. We give some input and we receive the output that alarm is set, right? So now the question is that we have to train the machine and we want that machine should perform the same function what our brain is doing, right? The question is, we say that we have a very supercomputer, we have high computational devices. So why we are looking for neural network? What is the benefit? Why we are going towards neural network if we have a supercomputer? If we have a high computational devices? So here I want to give some example, then it will be clear to you. Suppose you have a family members, right? You have your father, your mother, your siblings, your aunt, uncle, cousins, and you know very well that she is my cousin, he is my cousin, and they are my siblings and whatever, right? You know very well. And same thing, if we scan their pictures to our normal computer, suppose your father picture, right? Computer will give us the output that he is your father. Whatever training we will provide to this computer, to our normal computer, which we say our supercomputer or high computational devices. But what happens? Suppose one day your fathers come or your cousin come and he or she will change their getup. Now suppose your cousin is using the scarf or hijab, but still you know, you will recognize her that she is my cousin. If her face will be covered with the help of only eyes, you can recognize. This is our how our brain is working, because with the help of experience, we have our learning experience, we have seen her or him so many times, and we can say whether she or he is in a scarf or whatever get up. But if we will suppose the scarf cousin, we will give computer the new picture, we will not get the same output. This one was suppose without the scarf. We train the computer without the scarf that she is your cousin, whatever her name is, right? But if now suppose her getup is changed, we will not get accurate output, maybe 50%, maybe 60%, maybe 40%. So here we need the neural network, which was our topic, in order to get more accurate result. You can say that neural network is the learning algorithm, right? And how it works, simply I will explain to you in next few lessons. I will explain in detail. This is some functions x1, x2, or y1, y2, yn. These are our input. We provide some input, and input is in the form of raw data, and we some also add some weights, right? And here it will process. Here we will apply some functions, maybe quadratic, sigmoid, linear, whatever function, and then we will receive some output on the basis of our input. So this is the story of a neural network. Now the question is, what is the structure of the neural network? These kind of questions can also come in your exam as well, or some people can ask you structure of neural network. So this is the sequence you have to memorize. First we have input layer. You can say there are three layers: input layer, hidden layer, output layer, right? And you cannot say the first one is the hidden layer. No, this is the sequence: input, hidden, and output. And here I have made a very simple diagram. These are, suppose this is the input layer, the center one is the hidden layer, and this is the output layer. Here we provide input, right? Input is in the form of a raw data, and from here we will get the output. Do not worry about these lines. I will explain to you in the next slide. Just take these examples, right? These circles. And here, whatever we have learned in machine learning, that we have to train the machine learning. Similarly, we have to provide some learning or training here to our neural network. We provide some input, we train, and here neuron, here some processing, it will do some processing, and then after that we will receive the output. So input layer, hidden layer, output layer, right? And here I have written some information. Dendrites, what are the dendrites actually, right? We have dendrites. Human have dendrites and neurons. So what are the dendrites? Are projections of a neuron that receive signals from other neurons, just like I explained to you, because we are going to mimic, we are going to copy human brain to neural network. We are now trying to focus, we are trying to train the machine that you have to perform the same function what human brain is doing. So in human brain, dendrites and neurons are there, but here in neural network we cannot say that here we have also dendrites. Instead of dendrites and neurons, we have silicon and wires, right? Dendrites and neurons are belongs to human beings. But here we have used silicon and wire. So keep in mind, this is the structure. After a structure, working of neural network, how a neural network works. Again, we have to give some training. So it works parallelly like this. We have different processor. Suppose this is processor number 1, 2, and 3. Initially, what I said, we provide raw data or raw information, right? Just like in previous slide I said x1, x2, and so on. These are our input is always in the form of raw information. We do not have any conclusion here. Quickly again, I want to give some example. Suppose we have 100 papers, mix 100 papers. In some paper you can see there are math problem, in some there are physics problems, and there are chemistry problems. Suppose I want to know out of these 100 how many papers there are, how many papers on which you have solved the math question. So what you will do, you will do some sorting here. Suppose first paper you will take one by one paper belong to math, second, third, fourth physics, then is chemistry, then is again math, whatever. At the end you will say, Saima, there are 30 papers in which students have done their math questions. So this is my output, my required output, right? So initially it was the raw data, it was mixed. So same thing happened here. Raw information, we provide raw information to processor 1, which is called the input, right? Here processor 1 will perform some functions, and then it will produce some output, right? This is the input for P1, processor 1, and this is the output of P1. Now this output will go to processor number 2. When this output will come here, this will be the input for processor 2, and same thing, processor 2 will process, and then here again we will get some output. This output will be input for processor number 3, and again it will produce some output. This will be our result, just like this 30 papers. If if the output is the same what we are looking for, or our desired output is same, whatever it will produce is same what we are looking for, that is fine. If the desired output, this output is not the same what we are looking for, then we have to change this structure. What I said, if the output is same what we are looking for, if suppose I said 30, if it's producing 30, that is fine, I am looking for this result. If it is not the same, then we have to change the working of this neural network. But this is the simple working. There are parallel processor. We have to provide some raw information. First processor, we provide input. It will process and generate some output. So this output will be the input for the second processor output, and so on. So I hope the working is clear. Now types of neural network. So there are many types of neural network, but if you will see the books, these are the main or important, you can say. These three are important, but we have some more. So first one is feed forward, recurrent, and convolutional neural network. Now what is the difference? So here I have made some slides, right? First one is feed forward. See, name indicates feed forward. Here we supply the input, our raw information. Again, see here there are three layers: input, hidden, and output. And from here we will receive the output. When we will put some inputs, right? So you can see here, I will show you here, right? This one, this is the hidden layer, and this is the output layer. So we can provide data or whatever information. It can go only in one direction. So it is called feed forward is unidirection. It can go from here, here. It can go one to many, right? It will be one to many, but it cannot come back. If data is going in this direction, it cannot come back. This is the feed forward unidirection, and here we receive the output. See, you can see these arrows. It's going in one direction. See, in the last slide, I told you, do not worry about this. So these are the input, and see, the data is flowing in one direction. It can be from one to many, right? But it cannot come back. Second is recurrent. Recurrent is exactly same three layers: input, hidden, and output layer. Right? This is the output layer. X1, X2, X3 are our input. But in this case, data is going in both direction. If it's going like this, right? It can go one to many, but in both direction. It can flow in both direction. This is the difference between feed forward and recurrent. Last one is convolutional neural network. What happens here? It is exactly the same. What is the feed forward? Data is unidirection, but instead of hidden layer, there is one hidden layer. In convolutional, we have two hidden layers. So see how simple these types are. In feed forward, data is flowing only in one direction. Recurrent, data is flowing in both direction. Convolutional, data is flowing in one direction, but we have two hidden layers instead of one in feed forward. Right, there are some other types, but these are the main types you can find in your books. Now the application where we apply usually neural network. So here are a few more examples: NLP, natural language processing, stock market prediction, medical translation, right, question answering. Here are some examples. This is the most important: medical. Why? Because we are trying to mimic our brain to neural network. So neural network, you can say, is the base of biological neuron. And again, neural network is the learning algorithm. We have to train, and we have to say to machine, you have to perform the same way as human brains are working. So I hope the concept of neural network is clear. Please subscribe to my channel, share and like it. See you in the next lesson, and thank you.